This is Joshua Jude, presenting the Design Team Management Field Study Assessment. The building project selected for this assessment is a double-story residential building located in 15 Melville Avenue, Strathfield, which was completed in 2018. Involved in the development of this project is Danmore Consulting Engineers, an engineering firm specializing in structural, civil, and hydraulic engineering services and located in Concord, New South Wales. Their services also range from residential, commercial, and industrial developments. For this specific project, Danmore Consulting Engineers provided detailed architectural and structural drawings for the development of the project on the site. The chosen component that I will be discussing for this project are beams. In this development, various forms of beams were used, including timber beams, lintels, and T-bar beams to list a few. Additionally, the structural drawings showed many types of beam connections, such as double beam, timber beam to timber beam, and timber beam to joist, for example. The design and selection of beams is performed through close reference to specific standards and codes for use in a particular project, whether it may be residential, commercial, or industrial. The type of material of the beam is also taken into consideration, whether it is steel or timber beams being used for the project. In the role of a structural engineer, a wide range of skills and knowledge relevant to the design and fabrication of structures and other structural components is important. Structural engineers are primarily responsible for the structural design and detailing of beams, and therefore must have a deep comprehension of special loads, bearing on beams, types of loads such as permanent, imposed, and accidental loads, and properties of beams. Furthermore, structural engineers should be able to demonstrate mathematical, IT-related, and analytical skills, and have an understanding of basic compressive and tensile forces. Software platforms have transcended the way in which structural engineers are able to practice their discipline. New and improved programs have enabled structural teams to plan, design, and coordinate projects efficiently and run simulated tests to examine and resolve clashing components, through the use of Navisworks, for example, in addition to other structural engineering and analysis softwares like SCI Engineer and STRAP. The design documents for the development of this site include a first floor framing plan, roof framing plan, and framing details indicating the placement of the beams and providing sectional views of the beams connections. Looking at the first floor framing plan, various steel beams are employed in the framing of the structure. Angle bars are only used to the right of the entry, whilst T-bars and steel lintels are commonly used in the other sections of the plan. Next is the roof framing plan, which uses new and similar beams as previously seen. Square hollow sections are used at 90-degree angles throughout the roof framing in conjunction with angle bars and other beams. The main design features noticeable in both drawings are the beams which run through most of the load-bearing walls of the structure.